Okay, this is to go over the review guide and to get you ready for your test. So we're looking at question 1 here. And it says in quadrilateral MNOP, diagonals MO and NP are not congruent. So, means they're not the same size. But they are perpendicular bisectors of each other. And it also says that MO bisects angle M and angle O. And angle N and angle P are congruent. So it wants to know what's the most specific classification for the quadrilateral. Okay, so for this we kind of want to draw ourselves a sketch. Now, it doesn't have to be perfect, it is a sketch. So we know MO and NP are not the same size. So MNOP but we do know that they're perpendicular bisectors. So despite my, again, bad drawing, we know that that makes a right angle. We also know that angle N and angle P are the same size. Okay, and because they're perpendicular bisectors, we know this is the same as this, that's the same as that. And we know that MO bisects M and O. So we know this angle and this angle are the same, and we know that angle and that angle are the same. Okay, so it's a matter of what shape is it. So there's a lot of information here. Well, we can get rid of rectangle because in a rectangle the diagonals are the same. Because, you know, if we look at a rectangle, the diagonals are the same length, and these diagonals are not the same length. So rectangle's gone. If we look at a square, okay, again, the diagonals are the same length. These are not. So goodbye square. Now, in a rhombus, well, the diagonals aren't the same length, so that's a good start. They do make a 90-degree angle there. Again, good start. Good continuance, rather. It does bisect the angles. So, again, good for this. And for the shape in a hole, opposite angles are congruent, so it matches that. So, rhombus it is. Okay, so we really have to know our properties here. Okay, so make sure that you study your properties of quadrilaterals so that you know what fits here. Okay, question 2. Okay. Excuse me. So we've got a trapezoid that has an area of 24 square units. What are the coordinates of point C? Well, right here, we've got coordinates of A at -1, 2, B of -1, -1, and C of 8, -1. Okay, well, the area formula for a trapezoid is A equals 1/2 base 1 plus base 2 times the height. Well, right here, the height is the difference between 2 and -1. Well, 2 minus -1 is 3. So our height is 3. Now, we actually know our area is 24. Now, we know our base, one of our bases, is from -1 to 8. So 8 minus -1. So 8 minus -1 is 9. And we're looking for our other base. So we go through and we do this. Well, a couple of ways we can do this. I'm going to divide by 3. So that's 8 equals 1/2 times 9 plus x. Multiply by 2. Gets rid of the fraction. 16 equals 9 plus x. Subtract 9. And so 7 is x. Now, we are not done. Sorry, I'm off the screen. That's my fault. We are not done because that means this distance is 7. So we do -1 plus 7 and get 6. So the answer is C, 6, 2. Okay. Now, question 3. Find the measure of the numbered angles in the rhombus in the diagram. So one's angles 1, 2, and 3. Well, angle 1 is right here, and as we said earlier, the diagonals make perpendicular bisectors. So that means that's a right angle. So angle 1 has to be 90. Well, all of these say 90. Okay, so we know angle 1 is 90. Now, because these sides are parallel, and this is a transversal, that makes this and this alternate interior angles. So these are the same. So that means angle 2 is also 30. So 30, 30, 60, and 30. So choice C is out. Well, right now we have a triangle. 90, 30. Well, triangles have 180 degrees. So minus 90 is 90. Minus 30 is 60. So that means that's 60. Well, if that's 60, then that's 60. So angle 3 is 60. 70, 150, and 60. So D. Because remember, this is a bisector of the angle. So whatever one side is, the other side has to be also. Okay. Now, for question 4. Now, most people will want to find angle X first. But we can't do that because we don't know angle Y. Okay, so there's two different things at play here. Okay, First, we need to know how many degrees are in this shape. It's a trapezoid, and so the formula is S equals n minus 2 times 180. Well, that's 4 sides minus 2 times 180. 2 times 180, 360. So there's 360 degrees in here. Now, that's 115, and that's 60. And so we can take 115 away and get 5, 4, 245, and then we can take 60 away and get 5, 185. But that's not x because we haven't found y yet. So in order to find y, we have to do these. They make a linear pair. In other words, they add together to make 180. So 133 plus y is 180. So we subtract 133 and we get 7, 4. So 47 degrees. Well, that gets rid of C and D. So we've got 185 minus 47. Well, 15 minus 7 is 8. 7 minus 4 is 3. So 138. And so that's our x. So 138 and 47, the answer is A. Okay, so we have to find y in order to find x. All right, we can start x, but we have to find y before we can finish finding x. All right, question 5. Excuse me. Now, we did this one as a part of our warm-up the other day. So, in a pentagon, one angle measures 71 degrees. What is the total measure of the other 4 interior angles? So, we use S equals n minus 2 times 180 to find the total possible degrees. Well, that's 5 minus 2 times 180, which is 3 times 180, or 540. So that means there's 540 possible degrees in there. We know one of them is 71, so we subtract 71 degrees. That's 9. So 469 degrees are what's left. So if we look at a pentagon, now keep in mind this is a regular pentagon, so these are all supposed to be the same size. Or sorry, no, it's not a regular pentagon. Ignore me. So that means that one of these is 71 degrees. So that means angles 1, 2, 3, and 4 are what's left. Those 4 have to add up to that remaining amount, because it just wants to know what is the total of the other 4. Well, if we take away that from 540, that's what's left. So 469 is our answer. Okay, so we find the total measure, 540, and we subtract off what we know. What's left is our answer. Okay, question 6. Now, a regular octagon has an area of approximately 44.85 centimeters squared, a side length of 3 centimeters. What is the approximate length of its epithem? Now, there is a problem with the answer choices here, one of them is wrong. Well, let me rephrase that. All the answer choices are wrong because there's a typo, and so none of them work. So none of these answers are correct. What we should do is the formula A equals 1/2 SAN, where S is the side length, A is the apothem, and N is the number of sides. Now we know 44.85 is the area. 1/2 is the constant that we multiply by. We know the side length is 3. We don't know A, that's what we're looking for. And we know the number of sides is 8 because it tells us it's an octagon. Well, we do the multiplication we know. 3 times 8 is 24, and half of that is 12. And we divide by 12. And so 44.85 divided by 12 is 3.7375 or 3.74. So 3.74 centimeters is the correct answer. Now, based on what I'm doing, the way I set this up, I believe B is what I meant to be the correct answer. However, it is not a correct answer here. So this is what you should get though. Okay, this is the correct answer. All right. Now, for question 7. Now, admittedly, question 7 is an annoying question. It's the question where you have to do the distributive property, or not distributive property, the distance formula multiple times. Okay. You have to do AB, BC, CD, and then DA. And so the distance from A to B, well, -2 minus -1 squared plus 2 minus -1 squared. 3 minus -2 squared plus 3 minus 2 squared. 3 minus 3 squared plus 2 minus 3 squared. And then 3 minus -1 squared. Plus 2 minus -1 squared. And so we get -2 minus -1, so that's +1, so that's -1 squared, plus 3 squared, and then we get 5 squared plus 1 squared, and then 0 squared plus 1 squared, and then 4 squared plus 3 squared. Well, That's 1 plus 9, 25 plus 1, 0 plus 1, and 9, 16 plus 9, had it in the wrong order. And so that's the square root of 10, square root of 26, square root of 1, which is 1, square root of 25, which is 5. Now, in this case, none of these are the same, and so it is just a garden variety quadrilateral. In order to be a rectangle, you'd have to have two of the same. You'd have to have two pairs that are the same, and then you would do the diagonals, so AC and BD, and the diagonals would have to be the same. For a square or rhombus, they would all have to be the same, and then you would do the diagonals. If the diagonals are the same, it would be a square. If the diagonals are different, it would be a rhombus. For a rectangle, the diagonals would be the same. If the diagonals are different, it would be a parallelogram. If you have two pairs that are the same. Okay. Moving on to question 8. In the parallelogram shown below, we have these angles. The diagram's not to scale. Find angle 3. Well, in parallelograms, opposite angles are congruent. So that means angle 2 and angle 4 are the same. So we do 4x minus 26 equals 3x minus 15. And we solve that equation. So subtract 3x, subtract 3x. So that's x. Now, I'm going to do the next step in the same line. You don't have to. Plus 26, plus 26. So negative 15 plus 26 is 9. Or sorry, 11, sorry. So x is 11. That is not our answer. That is just x. So we can get rid of that right now. X is not, the answer is not 11. X is 11. So we do 4 times 11 minus 26. That's 44 minus 26. Well, 44 minus 20 is 24. Minus 6 is 18. Now, again, how many degrees are in this shape? Well, that's S equals n minus 2 times 180. Well, 4 minus 2 times 180. 2 times 180. So that's 360. Well, that's 18. That's 18. 18 plus 18 is 36. So subtract 36. That's 4. So 324. So angle 1 and angle 3 add up to 324. Well, angle 1 and angle 3 are the same size. So we divide by 2, and we get 162. Now, the other way to do this is to recognize that consecutive angles add up to 180. Okay, so what that means is angle 2 plus angle 3 will equal 180. Angle 3 plus angle 4 will equal 180. So if we know that that's 18, x plus 18 equals 180, subtract 18, x equals 162. Either method is fine. You pick which one works for you, and you will be perfectly fine. Okay. Now for the last question. It is a proof. And so this is our statements and reasons. Now, statements 1 and 2 can go in any order. KG is congruent to HJ. The reason that is that it's given. Then we've got HG congruent to KJ, also because it's given. Now, our ways to prove that something was a parallelogram were to show opposite sides are parallel, opposite angles are congruent, opposite sides are parallel and one pair of opposite sides are parallel and congruent. Consecutive angles add up to 180 degrees, or opposite sides are congruent. And well, right now we have opposite sides are congruent, so we can go straight to G, H, K, J is a parallelogram, and the reason is opposite sides are congruent. And we're done. That's the entire proof. Over, done with, kaput. A 3-step proof. They gave us everything we needed, and we just had to state the reason it was approved, that it was done. It can be done with more steps, but it is a lot more difficult. Let's just go with the easy one. Okay? If you have questions, send them to me on Teams, and I will answer. Good luck.